Okay, now that we have done sine, cosine, tangent, and secant, let's see how we can get cosecant to graph out in the Cartesian representation. So we're going to graph y equals cosecant of x. Well, cosecant is actually this brown distance right here in this representation. So let's look back at the unit circle representation. Remember what we've done is we've taken our angle, put it in standard position, rotate around here, and of course the input once again in all of these is the angle or arc length over here on the left, which is the angle in radians, and that's the same as the x value over here on the right. So the left is the unit circle representation, the right is the Cartesian graph representation. So we take this and we draw a tangent line to this point P on the unit circle where the terminal ray of our angle meets the unit circle, and then we look at the little triangle formed here I'll highlight the triangle here. There's the triangle right there. Okay, so that's the triangle we're looking at, which is a right angle there at P. Now, look at the angle. Our reference angle is actually down here. It's the angle from, well, it's the reference angle right down here. Here's the sides of it, there and there. Okay, but that's the same size angle as this angle up here at the top, currently at the top, this angle up here, because they're both complementary to this angle right in here. Okay, so the angle up here at the top is the angle we're going to be referring to. Now if you look at that angle, then this brown side is the hypotenuse, and the radius of the circle is the opposite side. So if you do opposite over hypotenuse, that's sine, but if you do hypotenuse over opposite, that's cosecant. Well, so that's going to be brown length, tan length there over the radius is cosecant, but the radius is 1. So the brown length is the cosecant. And so that actually is the cosecant right there of the angle that we need. Now the other thing is, notice that that's going to go from, well, the smallest it can get is 1, and then it could go up quite a bit larger. And notice when the x is in the, or when the angle's terminal side of your angle is in the first quadrant, this will be a positive number, okay, and same way here, whereas if we're down here it will be a negative number. So it'll actually be the y coordinate of this orange point that I have up here at the top will be the value. So let's go ahead and bring that over and just bring that y value straight over, and that's going to be the value of the cosecant. So let's look what happens to it. If we start at 0 here, it's actually undefined, but as we come a little bit bigger than 0, we're way up there, and we're working our way down to 1, which happens right at pi over 2, and then it goes back up again, higher and higher and higher and higher, going up towards infinity. So it's undefined at pi. Then when we're down here, in the when y is negative on your unit circle picture, in other words, a third or fourth quadrant terminal side for your angle, then the value of the cosecant and sine, both of those are going to be negative, and so we're way down here in the negatives, working our way up to negative 1 when it gets here at negative pi over 2 or 3 pi over 2, and then we work our way back from there down. So let's trace that out, and let's see what the whole graph looks like. And we see that this is tracing out as we go here. And so this is what the cosecant graph is going to look like. Now let's look at that in comparison to the sine graph. And if you remember what the sine wave looks like, then you're going to know that anytime that the graph of y equals sine of x hits the line y equals 1 or y equals negative 1, that at those places, in other words, the maxima and minima on the sine graph are going to be the minima and maxima on the cosecant graph. But of course, what's a maximum on a sine is a relative minimum on cosine. For example, one happens right there at pi over 2, and then another one happens at 3 pi over 2. This one has the other way around, though. This one is a point. It's another extreme value, but this one is a minimum on sine, both local and global, but it is a maximum on the cosecant. So the cosecant has a maximum when the sine has a minimum, and the cosecant has a minimum when the sine has a maximum. Right there. Okay? Notice that, of course, the cosecant doesn't have a global minimum or maximum. It only has a local minimum or maximum. Also notice that the cosecant never goes between -1 and 1, whereas the sine graph always stays between -1 and 1, except that they both do touch -1 sometimes and +1 sometimes. But other than that, the two graphs are really in completely different regions for the y values. Okay? So, once again, of course, these are reciprocal functions. So basic reciprocal relationship is the red distance here is the sine, and the light brown distance, well, just to here, is the from here to here is the cosecant, and it turns out that they are reciprocals of each other. And of course, the smaller you make one, the larger you make the other one, and vice versa in absolute value. Okay?